Hi students, welcome back. In this video, we are going to look at another linked list problem, finding the middle of the linked list. Let's look at the problem statement. So the problem statement says we are given head of a singly linked list. We have to return the middle of the linked list. So we have a head of the singly linked list and we have to return the middle node of the linked list. So if the linked list is of odd size, middle is very clear. But if the linked list is of even size, then there will be two middle elements. And in that case, we have to return the second middle node. Okay. So we are given head of a linked list. We have to return the middle element. So let's see an example. So in this example, the linked list has 5 nodes, 1, 2, 3, 4 and 5. Clearly 3 is the middle node. So we have to return that. In the second example, there are 6 nodes, so the even number of nodes. So there are 2 middle nodes in this case. So we will have to return the second middle node as per the problem definition, which is 4 in this case. Okay, so let's see how we can solve this. Let's take this example first. So let's say we take two pointers, index and a speed pointer. Okay. So a index pointer runs at the speed of 1, whereas the speed pointer runs double the speed, which basically means that by the time the speed pointer reaches the end of the list, the index will be at the middle of the list. So we can just return whatever is at the index. So let's see that with an example. Let's say we have the blue line represents a regular pointer which runs at the speed of 1 and the pink line represents a speed pointer. Okay. So initially when we started, both of them will be 1 at 1 and now the speed will go to 3 whereas index will go to 2. So in the next run, speed will go to 5. Okay. And index will just go by 1, right? So it will go to 3. If you observe, the pink pointer has already reached the end of the list. So at this point, we will return saying whatever is at the current index pointer, which is node 3 in this case, is the middle. Okay. Let's see if this works in case of uh, even number of nodes as well. So the regular index pointer goes at speed of 1 and the speed pointer will go at double the speed. So it will go next basically. So in the next run, this will go to 5. Okay. And index will go to 3. Okay. In the next run, this will go to the next of this thing, which essentially is null. Okay, there is nothing here, so it will just point to null. Okay, and now the index pointer will go to 4. So since this is at end, that means we have reached the end of the list. So the index pointer should have the middle element. So the idea is pretty simple. One is going at one, we are taking two pointers. One is going at twice the speed and one is going at the regular speed. So when the twice the speed pointer reaches the end of the list, the regular pointer will be at the middle. Okay. We have, first we need two pointers, index, and you will also need a speed pointer. Both of them point to head when we start. So when this is not equal to null and this dot next is not equal to null, we keep incrementing the pointers. Okay. So when either of them is null, that means we have reached the end of the list with the speed pointer. So the speed becomes speed dot next because it goes twice the speed, and index will just go to its next pointer, index dot next. We don't have to check for not null condition on index because index is always less than speed anyway, so it will always be not null. So now we just have to return the index. Okay. So let's submit it and see. Yeah, it got accepted. So we are traversing the list only once. So the time complexity is obviously order of n, where n is the size of the linked list. We are not using any extra space except for 2 pointers. So the space complexity is order of 1. Yeah, that's all we have for this video. Hope you liked it. Do practice and improve your coding skills. If you have any questions, do leave a comment. Please like, share and subscribe. Thank you.